Today, we are going to continue with electric field. This is the final answer for today's questions. Let us go through the questions now. Questions 1. Draw diagrams to show the electric field lines of the electric field due to a point charge of positive 2 microcoulomb and a point charge of negative 1 microcoulomb separated by a distance x. This question asks us to sketch electric field diagram, which means you have to sketch complete field diagram for both charges. It is unlike the vector diagrams that we use in the calculations, where we're just showing the directions of the vector. So here is the answer for these questions. As you can see here in this diagram, I have two charges, one positive 2 microcoulomb and the other one negative 1 microcoulomb. They are separated by a distance x right here. And then if you look at the directions of electric field line, since one is positive charge and one is negative charge, therefore the electric field line is going to leave the positive charge and entering the negative charge. And one more thing, if you look at the diagram, you will notice that they have different numbers of field lines. That is because the numbers of lines is directly proportional to the magnitude of the charge. So if 1 microcoulomb charge comes with 6 field lines, then 2 microcoulomb charge, you need to have 12 electric field lines. Questions 2. Three charges of magnitudes positive 0.2 microcoulomb, positive 0.4 microcoulomb, and positive 0.2 microcoulomb are placed on each corner of a right angle triangle with sides 3 cm, 4 cm, and 5 cm respectively, as shown in the figure. Determines the magnitude and the directions of the electric field at the right angle corner, where the charge of positive 0.4 microcoulomb is located due to the two positive 0.2 microcoulomb charge. Calculate the force experienced by the positive 0.4 microcoulomb charge. So in this question, it asks you to determine the magnitude of the electric field at this position. So how are we going to solve these questions? The electric field at the right angle corner. Step 1. Sketch field diagram. Now, this field diagram is unlike the diagrams that we sketched in questions 1. In this question, since we're going to use it in our calculations, therefore what we need is a vector diagram. So let us start from the original diagram. This is a diagram given. Before we sketch vector diagram, first we need to understand what does it mean by right angle corner and which charge is going to act as the object in this question. Right angle corner refers to the 90-degree corner right here, which means positive 0.4 microcoulomb charge is going to act as the object in this question. Before we proceed to the diagram, I would like to label the charge first. So I'm going to label this charge as Q1, here as Q2, and this one as Q3. Now that I'm ready, let us proceed to the sketching. So this is the object, which is a positive 0.4 microcoulomb's position. So what am I going to do right now? I need to identify how many charges is located beside it. So there is a Q1 and Q2 here, which means we're going to sketch two electric field lines based on these two charges. Let us start from Q1. Q1 is a positive charge. Positive charge, the field line is leaving the charge, which means the field coming out from this positive 0.2 microcoulomb charge will be pointing downwards when it passes through the red dot in the original diagram. Therefore, the electric field line coming from Q1 is pointing downwards. Let us repeat the same thing for Q3. if you look at Q3, Q3 is also a positive charge, which means the electric field line will come out from this charge. When it comes out from this charge and move forwards, it's going to pass us through the red dot and it keeps moving towards the left-hand side, which means the electric field line coming out from Q3 is going to be pointing to the left-hand side. So this is the diagrams that we are going to use in our calculations. Next, step 2. Apply electric field equation. For a point charge, we use E equals to KQ over R squared. Now, if you notice, I put a modular sign for charge, which means I'm going to ignore the negative sign of the charge when it comes to electric field. So substitute the values into the equations, and you will obtain E1 equals to 1.125 times 10 to the power of 6 Newton per Coulomb. And according to the diagram that we sketched just now, the direction of this electric field vector is pointing downwards. Let us repeat the same step for E3. So apply electric field equations for a point charge. We have E3 equals to KQ3 over R squared. So substitute the values into the equations and you will get E3 equals to 2 times 10 to the power of 6 Newton per Coulomb. Again, according to the diagrams that we sketched just now, this E3 is pointing to the left. Now that we have the magnitude of E1 and E3, let us proceed to the next step. Step 3. Resolve the vector into X and Y component. Let us look at the diagram. If you look at this diagram, you will see that these two vectors, they are pointing towards different direction. If they are not pointing towards same direction, you cannot simply add them up or subtract them. You need to resolve them by using this table. So let us start from E1. So E1, if you look at the diagram, E1 is lying on the Y component. Therefore, X component is equals to 0. And the Y component is equals to negative 1.125 times 10 to the power of 6 Newton per Coulomb. How about E3? If you look at E3, E3 is lying on the X component, which means the X component is equals to negative 2 times 10 to the power of 6 Newton per Coulomb. Now, the negative sign here, it indicates that the vector is pointing to the left-hand side. And the Y component is equals to 0 because this vector is just lying on the X component. Next, let us calculate the total field along the X component and the total fields along the Y component. So summations EX is equals to negative 2 times 10 to the power of 6 Newton per Coulomb, and summations EY is equals to negative 1.125 times 10 to the power of 6 Newton per Coulomb. Last step. Step 4. Calculate the resultant vector. Apply the equations for resultant vector. E2 equals to square root summation EX squared plus summations EY squared. Substitute the values and you will get E2 equals to 2.29 times 10 to the power of 6 Newton per Coulomb. Since you are looking at vector and the question is also asking for the direction, therefore we need to determine the angles for this vector. To determine the angles, we use equations tangent theta equals to modulus summations EY over summations EX. Rearrange the equations and substitute the value. You will then obtain theta equals to 29.36 degrees. But that is not the end yet. You need to explain where is this angle. You need to tell the reader the positions of this angle. How to determine the positions of this angle? Let us go back to this equation. If you look at summation EX, it is a negative value. Summation EY is also a negative value. Negative X, negative Y, which indicates that this new vector is now located in third quadrant. Therefore, how are we going to describe it? We're going to write it as below negative x-axis. So that is the end of these questions. Now that we have the electric field at the right angle corner, next we're going to determine the force experienced by the charge placed at the right angle corner, which is a force experienced by the positive 0.4 microcoulomb charge. Let us apply the equation E equals to F over Q naught. Rearrange the equations, you will get F equals to E times Q naught. Substitute the values and you will obtain F equals to 0.916 Newton. Remember, force is a vector, which means you need to state the direction as well. How are we going to determine the directions then? You look at the sign of this charge, Q naught. So Q naught in this question is a positive charge. Therefore, the direction of the force is in the directions of the field. If you have negative charge, then it will be pointing towards the opposite direction. So that's all for today. I will see you all again tomorrow.